Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mahdi bin Rosman, Geometry 082110071. Today I will explain our project with the graph flow measurement control system. I will explain my part with the proportional P controller with the KP equal 1.9 and P0 equal 25%. Firstly, we will find our P at 0 until 2, we will find our gradient m equal with the formula m equal y2 minus y1 divided by x2 minus s1. And then we'll insert the value of that with the negative 4 minus 0 divided 2 minus 0 equal negative 2. And then we will find our c with the formula y equal mt tambah y plus c, and we will get our c equal to 0. Then we will find our error equation with the formula EP equal mt plus c, and the final EP will get our negative 2t. Then we will find our controllable output for P equal Kp if P plus P0, and we will set our value with the Kp 1.9, EP negative 2t, and P0 25%. And the final we will get our negative 3.8 t plus 25. And then we will find our p at a 0 at the t equal 0 second. And we inside the value p equal negative 3.8 multiplied by 0 plus 25 equal 25%. And then at t 1 second, we will get our value 21.2%. And at 2 seconds, we will get our value 17.4. And then we will do the same thing at the 2 until 3 with the same formula m equal y2 minus y1 divided by x2 minus x1. And we'll get our m4. And then we will find our c with the equal negative 12 and error equation. We'll get our EP 40 minus 12. And at the controller output, we will get 7.6t plus 22.2. And then we will find our p at the t equal 2 seconds. We will get the value 17.4%, the same with the we find at the a. And at t equal 3 seconds, we will find our p equal 25%. We will do the same thing until t equal 15, and the final at t15 we will get our p equal 25%. And this is our table with the time second 0 until 15, and control output will get our value. And this is our graph with the starting of 0 equal 25% until 50 seconds with the value control output 25%. Then at the level measurement, we will do the same thing with the at flow measurement with the calculation and with the proportional controller Kp equal 1.9 and P0 equal 25%. The same 0 until 2, we'll find our M and we'll get negative 3, and then our C will get 0, and at error equation we'll get our EP equal 3t, and controller output will get 5.7t plus 25. We will get our P at t0 second with the value 25%, and at t equal 1 second we will get our P equal 30.7%, and at 2 seconds we will get our P 33.4. And we will do the same thing until the value t equal 10 seconds. with the value P equal 25%. And this is our table with the time 0 until 10 seconds and our control output. And this is our graph with the starting 0 second with control output 25% until 10 seconds with the value control output 25%. That's all from me. Thank you.
Assalamualaikum warahmatullah. My name is Muhammad SYAHM'IE bin Muhammad NAZLY. My matrix number is B08211030. So today I'm gonna present about our course, which is process instrumentation, our project that we have to do. So this is the project that I have to do, which is the calculation for the flow measurement control system and level measurement control system. So first of all, uh, my part is for the PD controller. So I'm from group 8. So my KP is 1.9, KD is 0.8, and P0 is 25%. So first of all, for the first question, which is the time 0 until 2. So we got the EP negative 2T. So this is the formula for the calculation. So the formula is Kp times Ep plus Kd Kp ddt Ep plus P0. So we're just gonna insert all the given to the formula, which is Kp we got 1.9 times by Ep negative 2T plus Kd 0.8 and times Kp 1.9, and for the dt plus Ep 0.2T and then plus 25. So just gonna cancel out this d and dt. So here we got the after we simplify, and then the answer is negative 3.8T plus 21.69. 96. So at first T at 0 second, we're just gonna insert from this answer, insert the time which is 0. So plus 21.96, and we got the answer 21.96%. For the 1 second, at time 1 second, we insert 1, and then we got 18.16%. And for the time at 2 seconds, we insert 2, so we got 14.36%. Okay, it's all the same. Just using the formula and insert the KD, KP, and EP. Okay, so this is the table for PD from 10 seconds until 15 seconds. So as we can see here, the output is barely up and down and up and down until the at 12 seconds the output is remain the same, which is 25%. So this is the graph for PD flow measurement. First, we're gonna how I'm doing this graph. So just insert the title times the S controller output. For the X axis, we put time seconds, and for the Y axis, we put controller output. So I'm putting increment of 5. So 5, 10, 15, 20, and I'm doing this graph using Excel. So just put all this table into Excel and convert it to the graph. So this is the graph for the PD flow measurement. So for the next question, which is for the level measurement control. Still, it is the same. We got KP 1.9, AD 0.8, and P0 25%. So same. The method is same. The formula is also same. The formula is using KP times EP plus KD times KP, and then for the bracket, DDT EP plus P0. So we put the numbers that provide into the formula. 1.9 times 3t plus 0.8 times 1.9 dt 3t plus 25. So after we simplify, and we got 5.7t plus 29.56. So for the t at 0 second, we just put the time, which is 0, to the t. We replace t with 0, and then we become 29.56%. At 1 second, 35.26%, and at 2 seconds, 40.96%. So for this question, A, B, C, all the same, just using the formula and insert the given. So, okay, for this controllers, this is the PD controllers output table. So it different from the flow. This time is only from 0 to 10 seconds. So this is the output from 0 to 8 seconds. It's not the same output, but until it become 8 and 10, the output is constant, which is 25%. Okay, so this is the graph for the controller output response level measurement. So the title, time vs controller output, the x-axis time in second, and the y-axis is controller output percent. So still same, I'm using 5 increment and 2 increment for the time. So convert this table into Excel, and then it become the graph. So as you can see here, from 0 second, the output is 29.56, and 1 second it increased 35.26, and 2 second it increased 40.96, and also in 2 seconds it decreased 27.28, and so on until the output until the time, which is 8 seconds, it become constant 25, 25, 25. Okay, that's all for me. Thank you.
Assalamualaikum and hi. My name is SYAZWAN bin Saleh, and my matric number is B08211103, and I will explain about a PI controller. So for the first section, I will use the KP is 1.9, KI 0.7, and PO equal to 25%. So for the P formula, KP EP plus KP KI, EPDT plus PO. So for the A section, it is from 0 second to 2 second. We will refer from the question table, and I get negative 2t. This is the formula P. We just plug in the number 1.9, multiply negative 2t for EP, and 1.9 multiply 0.7, 0 to t, negative 2t dt plus 25. 25 is the percentage of PO. And we get the equation, and after settle this down, we plug in for the time. Time is, we'll start with 0 second. So from this answer, we plug in we change t to 0, which is 0 second. So negative 3.8 multiply 0 minus 1.33 minus 0 square and plus 25, and I get 25%. Next, we move to 1 second. P equal negative 3.8 multiply with 1 minus 1.33 multiply with 1 square and plus 25, which is 25%, and I got 19.87%. And the third one is time for 2 seconds. P equal negative 3.8 multiply 2 minus 1.33 multiply 2 square plus 25, and I get the 12.08%. And I will do that repeatedly one by one until I get 15 seconds, and this is my result for 0 second, 1 second, 2 second till 15. And this is my chart. Error for flow measurement control system. And for the chart, you can see I will just plug in the number and I get this chart. This is control output percentage, and the bottom is time in seconds. So I get this one. This is the final graph. I will move to second question, which is level measurement control system. For PI, we will use the same as the question, which is KP equal 1.9, KI 0.7, PO equal 25%. We still use the same equation, which is P equal KP EP plus KP KI, 1 the number, T, 0 until T EP dt plus PO. So we start same as before, we start from 0 to 2 seconds. We will refer the timetable, the table that we got from the question. So we assume that EP is 3T. 3T we need to calculate this EP. So we start with P equal 1.9. And inside the P, from this equation, KPEP, so EP is 3T. 1.9 multiplied with 3T plus 1.9 multiply 0.7. 0.7 is KP. 0 until T, 3T dt plus 25.5 is the percentage of P0. So after we calculate this, we get the final answer, which is 1.995 T squared plus 5.7 T plus 25. And same as before, we plug in the time. The time for this, I start with 0 second. 1.995 in bracket 0 square plus 5.7 in bracket 0 plus 25, and I got the 25%. This is the start. And next, I move to 1 second. So we just plug in the T with 1 second, which is 1. So 1.995 in bracket 1 square plus 5.7 in bracket 1 and plus 25. We got 32.66%, and move forward. We plug in 2 second. P equal 1.995 multiply 2 square plus 5.7 multiply 2 plus 25, and we got the 44.38%. And this is my final result. We just do that repeatedly and change it, refer to formula and the time. So I do the time from 0 second to 10 second. This is my final answer, and this is the graph that I got from the equation. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Danial. May I NIZAM. My matric number is B08. 2110373. So I'm gonna explain about PID controller calculation and graph that I get for the results. So as we can see in PID controller, the KP for my group is 1.9, and K1 KI is 0.7, KD 0.8, and PO is 25%. So as you can see, the formula for determine the P, which is PO, is KP. I'm using KP, EP plus KI, KP, and then Euler T20, EP again, DT plus KD, KP, and DEP over DT plus P0. So within the information given above, I use the information and put into the equation to get the results for my calculation. So in this PID controller, for figure 1, I use the same method for determine the P, and to determine the T, where at T equals 0 or 1 or 2 or 3, I'm using the equation which is here, P equals to KPEP plus KI, KP, Euler T to the time that we want to use, EP and DT plus KD, KP, and then D, EP, differentiate EP with DT plus P2, or P the previous, P for the using calculation lah. So within the information above, uh, to determine T, I use the same information, and for the next question, I use the previous question information. So it's actually a chain of a question. It relates between each other. So as we can see here, and here I'm using all the same equations. So as for the result, I prepared a table and the graph for the results. So at the left side of the table, we can see the time, which is 0 until 15, and the control output that I gain is in the calculation, and this is the results. And from the results and the table that I create a table that consists a graph, a linear graph, and for 0, we got 21.69, and for 1, 2, 3, 4, 5, 6, 7, and above, all of this got their value, which is 16.83, 2, 18.16, and 3, 23.1, 4, 27.19, at time 5, 28.695, and so on. As for the second one, I use the same method also, which and using the same information that given into our lab no no project assessment, which is my group, uh using KP as 1.9, KI 0.7, KD 0.8, and PO still 25%. So as you can see for figure 2 also, I use the same equation, which is P. To determine P, I use KP EP plus KI KP T to 0 EP and DT plus KD KP DEP and DT plus PO. Different from the other question, for determine the P from the previous question, the question 0 doesn't need the P for the because it's the starting equation. So after this question, it's a chain question, which is it relates into each other. So I have to determine the EP and use other equation, which is KP EP plus KI KP. For determining P, which is P3, for example, KP KI Euler T22 EP DT plus P2. And for determine the P for the current P, which is Kp EP plus Ki Kp, Euler T to the current value, EP dt plus Kd Kp, and dep differentiate differentiate EP with dt plus P with the current value. So for the result for this figure, um, I also create a table, which is, as you can see, from the left side, we got time 0 to 10 and control output from 29.56 until 431.37%. So from this table, I create a graph that we can see it's increasing, and one of the time each time got their value, which is 0, 2.9 to 9.56, and 2, 3, 5.26 for at second time second 4 second 4.47.04, 6 198.0609, and for the 10 second 43 431.37 second. So as you can see, the graph is increased. So that's all for me. My name is Aiman Danial, and thank you for watching.